Hello students, this is Mr. Maat with another physics lesson. Well, in this lesson I'm just going to continue on the theory from previous lesson and we will talk about amplitude, wavelength, frequency and cycle time again. Well, I created some assignments, we will do those together and then I have a handout and the link to the handout is attached to this video. There's also some homework for next lesson, so make sure that you finish all those questions. Okay, little recap about the theory. This was a representation of a sound wave. The first thing that you should know is that the amount of waves per second or the amount of oscillations per second, we call that the frequency, represented by a lowercase f. Well, the time that it took for actually one complete wave, we call that the cycle time or the period time. Well, remember that in the vertical direction you always talk about the amplitude and in the horizontal direction you talk about the frequency. So the loudness versus the pitch. Well, there were two formulas that you should remember from the previous lesson. That was the formula to calculate the frequency in hertz is 1 divided by the cycle time. Make sure you insert the cycle time in seconds to get to hertz. And the formula for the cycle time or the period time is capital T equals 1 divided by F. Well, if you now know those formulas, you should be able to finish the next questions. So please stop the video for a moment and finish those questions, please. Okay, the most important thing over here is that you make sure that you work with standard units. You see over here 150 Hertz, 5.0 kilohertz, 25 megahertz and 45 seconds. Now, the first one is easy, that's the standard unit. So you can just fill in the formula and you get this outcome. 1 divided by 150, you get 6.7 times 10 to the power of minus 3 seconds. But this one, you need to calculate the period time, and that is, the frequency is given. So, but the frequency is given, but it's given in kilohertz. And kilo always means multiplying it by 1000, so you get 5000 hertz. You fill it in and you get 2.0 times 10 to the power of minus 4 seconds. Over here we're talking about the cycle time. I just told you that incorrect, it's not 25 megahertz, it's 25 millihertz. If it's millihertz, of course you need to divide it, and that's why you get 0.025 hertz. Now I have standard units, fill it in, I get 1 divided by 0.025 and the outcome will be 40 seconds. Well, over here there's a standard unit given, 25 seconds, so you want to know the frequency. If you just fill it in, you get 0.022 hertz. Okay, so far calculations if you need to work with cycle time or the frequency. I created a handout, and the thing that I want you to do, I want you to stop the video and just finish this handout. I will go through all the questions and I will show you the answers. So pause the video and then I'll continue. So the first one is this, fill in the missing words. Cycle time, frequency, amplitude, wavelength, frequency again, period time and amplitude. Well, here are the results. Let us first start with the amplitude. Well, that is of course the vertical displacement of that molecule. So that is the amplitude. The amplitude is also given over here. Then this is going to be the cycle time, the time that it actually took for one wave. And why did I write down cycle time instead of, for instance, wavelength? Well, you always need to take a look at the axis. Over here there is time given, so we're actually talking about cycle time and frequency. If there was length given over here, then we should talk about wavelength. So that's why wavelength is not in this figure now. So the frequency is how many waves there are in 1 second. Well, it starts over here at 0.6 and it ends up at 1.6, so that's exactly 1 second. Again, here's the period time, that is the same as the cycle time, and the frequency is over here. So that was assignment number 1. Let's go to assignment number 2. In assignment number 2, a sound wave is given and you see the amplitude over here. There is a table in your reader on page number 23 and you need to use that table. First one is draw a sound wave with a loudness of a normal speech in a diagram. Well, over here I see a sound wave and it has a maximum amplitude of 150 decibel. That is on the vertical axis. Well, if you search at the table, you will find that a normal speech, the loudness of the normal speech is approximately 55 decibel. So the sound wave, the amount of waves per second, the frequency, is still the same. The only thing that changes is the volume, so the top drops to 55. Make sure you keep the frequency, the amount of waves, the same. Now draw a sound wave with the loudness of a jet plane. Well, the jet plane is like this. The jet plane has a loudness of 100 decibels. You should draw a graph that looks a bit like this, same frequency, but again, the volume drops a bit. Then this question number 3, there are 2 waves given. The question is this: which wave has the highest pitch? Well, the highest pitch you're talking about if it's a high or a low tone. Well, the higher the tone, the more waves you have, so the bigger the frequency. So the highest pitch, the sound wave with the most waves is of course sound wave number 1, because take a good look. In 1 second, sound wave number 1 has 2 hertz, and this one only has half a hertz. So the pitch is higher in sound number 1. Which wave is the loudest? The loudest, you always need to focus on the amplitude. The amplitude was in the vertical direction. Well, in this case, both waves have an amplitude of 3 decibels. So that's exactly the same. What is the frequency of wave number 1 and the frequency of wave number 2? Well, I already showed you that. You just need to count how many waves you see in 1 second. So sound number 1, this is 1 wave, 2 waves in 1 second, that means 2 hertz. Sound number 2 is only half a wave, because this is the complete wave of sound number 2. So half a wave in 1 second, that means half a hertz. Is it possible for humans to hear those frequencies? Well, you all know that the frequency range of humans starts at 20 hertz and it ends up at 20,000 hertz. Well, the frequencies 2 hertz and 0.2 hertz, well, don't lie in that range, so we can't hear those. Well, there is some homework, of course, for next lesson, so make sure that you finish lesson 2.8.5. Thanks for watching. If you like this movie, thumbs up. See you next lesson.